Hi, it's Liz Sneddon. Let's have a look at talking about shapes for comparison investigations. So we've got these different shapes here that we need to know. So we've got our left and our right skewed, which has got a tail on the left hand or the right hand side. We've got our normal distribution, which looks a bit like a hill with one peak, pretty symmetrical. We have bimodal, where there can be two main distributions. And we've also got uniform, which is when we've got some very straight sides and quite a flat top. So two quite common ones that we want to be able to recognise are our left and our right skewed. So with the left skewed, there's a longer tail on the left hand side and the data is all packed together on the right hand side. Vice versa, right skewed has the data packed on the left but a long tail on the right. So it's always the direction of the long tail. When we justify the shape, here's three things that we want to think about. We want to think about the number of peaks. Now I'm not talking about the modes, how many tall individual modes there are. I'm looking at a general pattern of peaks. Okay, I want to know if there is skewness and I want to know whether or not it's symmetric. So if I look at this example here, I'm looking for a general pattern. So I don't want to see this kind of skyline approach and kind of every little up and down you go around. We don't want to do that. What we want to do is something like this, where it's a very general swish over the top, and then we want to identify what pattern that is. So we want to think about it as if it's coloured in and think, okay, well that looks like two main peaks. That might be bimodal data. So let's look at our example here. So we've got our wall sit times for males and females. Draw our line over the top and shade it in. So for females, it looks like there's more data on the left and it's a bit more spread out, longer tail on the right hand side. So that to me looks more like a right skewed distribution. So that's what we want to say. In my sample, I noticed the shape of the distribution of the time that female students can do a wall sit for is right skewed, because there's a longer tail on the right hand side. So notice I refer to the group, the female students, and I refer to the distribution of time that they do a wall sit for. So I'm referring to the numeric variable. Let's do the same kind of thing now for our males. So males, we do the shape over the top, colour that one in, and think again the data's a lot more data on the left hand side, a little more spread out, longer tail on the right hand side. So that too looks like the male sits, that their distribution of times for wall sits are also right skewed because they have a longer tail on that right hand side. Thanks very much for watching.